we are first going to look for the x-intercept. We set y equal to 0, therefore x is equal to 0. As expected, the x-intercept is 0, 0. We can see it from the graph. For the y-intercept, x is equal to 0. We obtain 0 over square root of 2, which is 0. And the y-intercept is also 0, 0. For the vertical asymptote, we set the denominator equal to 0. And we realize that x equal to square root of negative 2 is not a real number. No vertical asymptote. For the horizontal asymptote, we have to look for the limit of f of x as x approaches plus or minus infinity. If we understand f of x to be x divided by square root of x squared over square root of x squared plus 2 divided by square root of x squared, notice that square root of x squared over square root of x squared is 1, so we didn't change the rational expression. As x approaches infinity, positive infinity, x is positive, therefore the square root of x squared is equal to x. Now x is approaching infinity, which means that x is going to be extremely big. X over x will be the numerator, and square root of x squared over x squared, which is 1, plus 2 over x squared. X over x is just 1. So that limit will be as x approaches positive infinity, x over x, which is 1, divided by square root of 1, because 2 over x squared will become 0, small over extremely big. So that limit is 1. As x approaches negative infinity, x is negative, so the square root of x squared will be equal to the opposite of x, so it's going to be negative x. And f of x will be approaching x over square root of x squared, which is negative x, over x squared, which is 1, plus 2 over x squared. It's going to be over the square root of 1 plus 2 over x squared. X over negative x is negative 1, and the square root of 1 plus 2x squared is just the square root of 1. So that limit as x approaches negative infinity will be negative 1. Conclusion: the horizontal asymptotes are y equal to 1 and y equal to negative 1. Now we're going to look at the derivative, and we're going to write f of x with fractional exponent. So it's going to be x over x squared plus 2 to the 1/2. Quotient rule. So it's going to be 1 times x squared plus 2 to the 1/2 minus u, which is x, times v prime 1/2 x squared plus 2 to the 1/2 minus 1, which is negative 1/2, times the derivative of the inside, which is 2x, divided by x squared plus 2 to the 1/2 to the second. F prime of x, when we simplify, will be x squared plus 2 to the 1/2 minus the 2 cancel, x times x is x squared times x squared plus 2 to the negative 1/2 over x squared plus 2 to the first. Now we're going to factor the least power, which is the GCF, x squared plus 2 to the negative 1/2. And we are left with x squared plus 2 to the first, because 1 plus negative 1/2 is equal to 1/2. So when we factor it out, we have to put 1 as the exponent. And the second expression has the least power, so it's just x squared over x squared plus 2 to the first. Negative exponent will be brought down to the denominator, and 1/2 plus 1 is 3/2. So it's going to be x squared plus 2 to the 3/2. And x squared minus x squared is 0. The first derivative has no critical numbers, no extrema. Second derivative, the second derivative will determine concavity. We will write f prime of x with a fractional exponent. 2 times x squared plus 3 to the negative 3/2. And the second derivative is 2 times negative 3/2 times x squared plus 2 to the negative 5/2, 3/2 minus 1, times the derivative of the inside, which is 2x. 2 over 2 is 1. Simplify by 2. We'll get negative 3 times 2x, negative 6x as the numerator. We kick the negative exponent to the denominator, x squared plus 2 to the positive 5/2, which can be written as negative 6x over square root of x squared plus 2 to the 5th. X squared plus 2 is always positive, to the 5th is always positive, and the square root of a positive number is positive. So the denominator is always positive. The sign of the second derivative will depend on the numerator, negative 6x. Test before 0, a negative times a negative is a positive. Test after 0, a positive times a negative is negative. So from negative infinity to 0, the curve is concave up. And from 0 to negative infinity, the curve is concave down, as indicated by the graph.